Hey there, students, and welcome! Today we're going to master a really important keyword in Java, final. Now I know, it's just one little word, but trust me, it is incredibly powerful. It's really the key to writing code that is safe, predictable, and solid. Plus, understanding this is a super common topic in technical interviews and exams, so you'll want to pay close attention.
So let's kick things off with the big question that final actually solves. Have you ever wondered, how do you make sure certain parts of your code just stay put? How do you make them permanent? Well, by the end of our time together, you're going to know exactly how to use final to lock down everything from variables and methods to entire classes. Let's get into it.
Okay, first up, let's talk about the most common way you'll see the final keyword used, with variables. When you slap that final keyword on a variable, you're basically turning it into a constant. Think of it like this. Once you give it a value, that's it. It's locked in for good. You can't ever change it.
Now you might be wondering, why would I ever want to do that? Well, just imagine you're building a program that needs the value of pi for some calculations. That value is, a universal constant. If some other part of your code could accidentally change it to, say, 4, your entire program would go haywire. Using final is what stops that from ever happening.
Let's look at this in some actual code. Over on the left, you see a normal variable, speed limit. We set it to 60, and then later we can easily change it to 80. No problem, right? That's business as usual. But now, look to the right. We've added that one little word, final. And when we try to change max speed, bam! The Java compiler throws an error. It won't even let you run the code. It's like a built-in guard.
So here's the key takeaway, and this is a big one for your exams. A final variable is a constant. Its value cannot be changed after you assign it. You have to give it a value exactly one time, either right when you declare it or inside the constructor. That's the rule.
All right, so we've locked down a single value. But what if we want to think bigger? Let's move on to the highest level of control, the final class. Here, we're not just locking a value, we're locking down an entire class blueprint. Think about some of the most important classes in Java itself, like the string class. Its behavior is absolutely fundamental to how Java works. Now, imagine if other programmers could just create their own versions of string and change how it behaves. It would be total chaos. To prevent that, the creators of Java made the string class final.
So here's a pretty standard setup in programming. We have a parent class, let's call it calc, and then we have a child class, advanced calc, that extends it to add some new features. This is a totally normal and essential part of object-oriented programming. It's how we build on existing code.
Now watch what happens. On the left, inheritance works just like we'd expect. But on the right, we declare our calc class as final, and that one keyword changes absolutely everything. The advanced calc class now tries to extend it, and the compiler just says nope. It throws an error. The blueprint is officially sealed shut.
This is a really important concept. A final class can never be a parent class. It's the end of the line for inheritance. And this is a super powerful tool for security and for making sure that the core parts of a big system or framework stay stable and reliable.
Okay, next up, final methods. This is where we get really precise. What if you want to let other classes inherit from yours, but there's just one specific behavior, one specific rule that you absolutely cannot let them change? That's where final methods come in.
For example, let's say you have a method in your parent class that runs a critical security check. You need to be 100% sure that every single subclass uses that exact same security logic without any modifications. This is the perfect time to make that method final.
And let's see this in action. On the left side, the advanced calc class overrides the show method from its parent. This is totally normal method overriding. But on the right side, we add the final keyword to the original show method in the parent. Now when the subclass tries to create its own version, the compiler steps in and stops it cold with an error. So remember this rule, because it comes up a lot in interviews. A final method locks down an implementation. Subclasses can still inherit it, they can still call it and use it, but they are forbidden from ever changing it.
All right, let's bring it all home and do a quick recap of everything we've just learned. This is perfect for that last-minute review right before an exam or a big interview.
So the final keyword gives us control in 3 different ways. First, a final variable acts as a constant, basically locking in a single value. Second, a final class stops inheritance, locking down the entire blueprint. And third, a final method stops overriding, which locks in one specific rule or behavior.
You know, the really crucial thing to get here is that using final is the mark of a thoughtful programmer. It's how you write code that is stable, predictable, and secure. It's you, as the programmer, communicating your intent and saying, hey, this part of the design is foundational. It's not meant to be changed.
So as you go forward with your coding, I want you to think about this. Where in your own projects can you apply this idea? What values, what behaviors, or what designs are so critical that they deserve to be made permanent? Thanks for hanging out with me today. Keep practicing, and good luck.